All right, so now that we are here and we are able to define these side lengths, we're going to start using them with some ratios. We're going to actually do the trigonometry now. So let's draw a fresh triangle. It's a right triangle, so we know that we can do trig. Second, we're looking at angle x, and let's say this is 3, 4, 5. So those are the side lengths. So all of this is given. We haven't solved for anything yet. Again, the question is given to us. That's what we're starting with. So first things first, identify the angle, label the sides. Hypotenuse across from our 90-degree angle is going to be 5. We'll call that h for hypotenuse. Second, touching the angle is adjacent. So literally next to that x angle, that is adjacent. And then last thing, directly across from our angle is our opposite side. So my advice to you at this point is actually make things very clear. Label O equals 3, A equals 4, and H equals 5. So now that we're at this step, we can actually start doing some solving. We can either solve for the degree measure of x, or if any of the sides were missing and we were given the angle, we could do it the other way around as well. So a couple of ratios, and here are some definitions for your notes. Based off of what we have here, there's actually 6 different ways that we can solve for angle x, and we'll go through each of them. So the first way is with the sine of angle x, and the sine of angle x is always equal to opposite over hypotenuse. That's the SO from SOHCAHTOA. Next, we have the cosine of angle x. That is the CA. It is the adjacent over hypotenuse. After that, we can use tangent. The tangent of angle x, that is the TOA, is O over A, or opposite over adjacent. Additionally, we have the inverses of these. So our inverse of sine is cosecant, or CSC. So the way you say that out loud is cosecant. So the cosecant of angle x is just the upside down version of sine. Our secant of x is just the upside down of cosine. And then finally, our cotangent of x is, again, the upside down of tangent. So these are the 6 trig ratios that we can use. Your calculator works for all 6 of these. It gives us some choices, and there are some scenarios where we're going to have to use one or the other of them. So some good things to see here, some useful skills when plugging into the calculator. So let's go through how do we solve for these things. So O over A, O over H, A over H, A over A, all of these things we are able to do. At this point, it just turns into substitution. So O is 3, we'll make that red, we'll make A green, which is 4, and then finally we'll make H blue, which is 5. And we can write out each of these ratios. So the sine of x equals the opposite over the hypotenuse, or 3 over 5. Secondly, the cosine of x equals the adjacent over the hypotenuse, or 4 over 5. And then finally, the tangent of x equals the opposite over adjacent, or 3 over 4 this time. So let's take a look. Our opposites, we said that we would make those 3, and they would be red. Our adjacents are green, and those are 4s. And then finally, in blue, we have our hypotenuses, or 5. So all of these things here match up with color coding from the side. Now we can do the same thing for our other trig functions. So cosecant is 5 over 3. Secant is 5 over 4. And then our cotangent is equal to 4 over 3. So there's no real computing here that we're doing. It's just labeling some ratios. So the ratio of sine x is 0.6. So that's kind of the goal for this part of the video, is take some of these functions and practice plugging in. Identify O, A, and H, and put them in